Good day, sir. I'm Ace Lauron, a BS AA 2A student. So here is my video presentation in Module 1. To determine a diagram, whether it is a series circuit or a parallel circuit, we must first analyze the diagram. So a series circuit diagram, the flow of electricity is in a single path, while in the parallel circuit, the flow of the electricity is in a multiple path. So to find the equivalent resistance of a series circuit, we must simply sum up all the values of the resistor. So total resistance is equal to R1 plus R2 plus R3 plus R4. So in parallel circuit, it is just a reciprocal of the equivalent resistance of a series circuit. So 1 over the equivalent resistance of a parallel circuit is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. In series circuit, there is a single current that will flow through each resistor. It means that the total current is equal to the current in resistor 1, the current in resistor 2, and so on. So in parallel circuit, the total current is equals to the current through the resistor 1 plus the current through resistor 2 plus the current through resistor 3 and so on. So to solve each current in each resistor, we need to use the Ohm's law, wherein V is equals to IR, or the voltage is equals to current multiplied with resistance. So to compute the current in resistor 1, so total voltage over resistor 1, and then the current in resistor 2 is equal to the total voltage divided by resistor 2. The current in the resistor 3 is equals to the total voltage over resistor 3 and so on. Total voltage in series circuit is equals to the voltage to the resistor 1 plus the voltage to resistor 2 plus the voltage to resistor 3 and so on. So to solve each voltage in each resistor, we need to use the Ohm's law, wherein the voltage is equals to current multiplied by resistance. So the voltage drop across the first resistor is equals to total current multiplied by resistor 1. And the voltage drop across the resistor 2 is equals to the total current multiplied by resistor 2 and so on. In parallel circuit, the total voltage is equal to the voltage through each resistor. So it means that the total voltage is equals to the voltage of the resistor 1 is equals to the voltage of the resistor 2 and so on. In series circuit, if we add a resistor, its resistance will rise up and its current will lower down, while in parallel circuit, it is inversely proportional to the series circuit, wherein if we add a resistor, the resistance will be lowered down and its current will rise up. So a 9-volt battery is connected to a series circuit which has a resistor of 6 ohms, 1 ohm, 7 ohms, and 3 ohms. So number 1, find the total resistance. So to find the total resistance, of a series circuit, we need the formula RT, or the total resistance, is equal to R1 plus R2 plus R3 plus R4. Since we have 4 resistors, so the total resistance is equal to R1, which is 6 ohms, plus R2, which is 1 ohm, plus R3, which is 7 ohm, plus R4, which is 3 ohms. So to find the total resistance, we need to sum up. So 6 plus 3 plus 1 plus 7. So the total resistance is equals to 17 ohms. So number 2, find the total current. So to find the total current of a series circuit, we need the formula IT, or the total current, is equal to V, or the voltage of the battery, divided by the RT, or the total resistance. So 9 volts divided by 17 ohms of resistance. So 9 volt divided by 17 ohms. So the total current is 0.529 amps. Number 3, find the voltage drop across each resistor. So to find the voltage drop in each resistor, we need the formula V1, or the voltage drop of the first resistor, is equal to the total current multiplied by the first resistor. So the total current is equal to 0.529 amps multiplied by the first resistor, which is 6 ohms. So 0.529 amps times 6 ohms is equal to 3.174 volts. So the voltage drop on the second resistor, so V2 is equal to the total current multiplied by the second resistor. So 0.529 amps multiplied by 1 ohm is equal to 0.529 amps multiplied by 1 ohm is equal to 0.529 volts. And then the third resistor, so the voltage drop across the third resistor, which is V sub 3, is equal to the total current multiplied by the third resistor. So 0.529 amps times 7 ohms, 0.529 amps times 7 ohms is equal to 3.703 volts. So the last resistor, V sub 4, or the voltage drop across the fourth resistor, is equal to total current multiplied by the fourth resistor. So 0.529 amps times 3 ohms, 0.529 amps times 3 ohms is equal to 1.587 volts. So the voltage drop at the first resistor is 3.174 volts, and the second resistor is 0.529 volts. And the third resistor, which is 3.703 volts. And the fourth resistor is 1.587 volts. So the total voltage drop is equivalent to the original voltage, which is 9. So problem number 2. A 24 volt battery is connected to a parallel circuit which has a resistor of 12 ohms, 16 ohms, and 8 ohms.
Morning light music.
So number 1, find the equivalent resistance. So to find the equivalent resistance, we need the following formula. 1 over the equivalent resistance is equal to 1 over R1, or the first resistor, plus 1 over R2 plus 1 over R3. Since we have 3 resistors, so to make it simpler, I raise both sides by -1. So it will become the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 raised to the power of -1. So to find the equivalent resistance, we need to calculate. So 1 over R1, which is 12 ohms, plus 1 over R2, which is 16 ohms, plus 1 over R3, which is 8 ohms, then raised by -1. So the total resistance is equal to 3.692 ohms. The number 2, find the total current. So there are 2 ways on how to solve the total current. So I use the simpler one. So total current is equal to voltage of the battery divided by the total resistance. So the total current is equal to 24 volts divided by 3.692 ohms of resistance. So to calculate, 24 volts divided by 3.692 ohms is equal to, the total current is equal to 6.5 amps.
Morninglightmusic.com.
So number 3, last number. Find the current through and the voltage drop across each resistor. So to find the current through each resistor, we need the following formula. I1, or the current along the first resistor, is equal to voltage of the battery divided by the R1, or the resistor 1. So 24 volts divided by 12 ohms. So the current through the resistor 1 is 2 amps. So I2, or the current along the resistor 2, is equal to voltage of the battery divided by the resistor 2, which is 24 volts divided by 16 ohms. The current through the resistor number 2 is equal to 1.5 amps. Then the current through the resistor number 3 is equal to voltage of the battery divided by the resistor number 3. So equals to 24 volts over 8 ohms. So the current along the resistor number 3 is equals to 3 amps. As what the module said, the voltage drop across each resistor is equal to the total volt. So VT, or the total volt, is equals to the voltage 1 of the resistor 1 is equals to voltage 2 of the resistor 2 and voltage 3 of the resistor 3. So the other formula in finding the total current is total current is equal to the I1, or the current 1, which is 2 amps, plus I2, which is, and the current 2, 1.5 amps, plus I3, which is the current 3, which has a 3 amps. So the total current is also 6.5 amps.
Morning Light Music.